Hi there. I wanted to make a couple of videos about some work I've been doing combining pen plotter output and slime mold or Physarum algorithms on the GPU. So my basic process is I make an image on the pen plotter. I use Copic markers on Yupo paper, which gives some really nice blending effects, and I'll link to those down in the description. So I make this pen plotter thing, and then I scan it, and then I apply the Physarum algorithms to the scan. So in this video, I just want to talk about how I do the pen plotter. I wrote a little program which makes the kind of radial shapes that I like a little easier to use or to create. So I'll walk through the code for that and show the plotter working and then show the scan at the end. And then I'll have another video which is about processing that piece in my slime mold GPU code. All right, so let's get started. All right, so let's talk about the program that creates the output for the plotter. Basically, what this program does is it defines some boundaries for shapes, concentric shapes, essentially, and then draws the border of those shapes and then lines which connect each point on those shapes. So this boundary list here is what defines those shapes. And then each shape here is an item in that list. And each shape is given a radius, which should be self-explanatory. These are in millimeters, you should note, and we're using A4 paper size here. So we have to be careful not to go outside the paper size. So the outer one is a radius of 90, frequency of 1. I'll talk about what frequency means in a minute. Start of 0, which is basically when we start drawing that shape, how many radians do we offset from the normal start? And then resolution is basically how many segments there are in each shape. So for our set of boundaries to start with here, we've got one with a radius of 90, another with a radius of 60, and they both have the same number of segments, the same frequency, and the same start. So we should expect two concentric circles with lines between them. And when we run it, that is exactly what we get. So you can see here that they're blue one's the outer one, that's radius of 90. Orange is the inner one, radius of 60. And then just lines connecting these segments. So that's pretty boring. I wouldn't bother sending that to the plotter. But let's make this a little more interesting. So one thing we can do is define a thing called an epicycle here. And that also is given a radius. So we'll give this a radius of 12. It's also given a start offset. We'll say 0. And it also is given a frequency. And the frequency starts to matter more for these epicycles, because what they are is, if you think about the anchor point going around with a radius of 90 and a frequency of 1, the epicycle is a circle that's sort of drawn on that anchor point as it goes. So we'll give this a frequency of 6 here. And you can sort of think about this as like a moon orbiting a planet as the planet orbits the sun. Same sort of deal here, obviously two-dimensional, but when I run this, you should see it got bumpy and kind of weird. And one of the interesting things to note is these segments get longer sort as the epicycle goes to the outside of the radius. So this is when it's kind of around, like you can imagine a constant radius around here, and then this gets offset to the outside or the inside. When it's on the inside, it's almost doubling back on itself, which makes these lines a lot closer, which starts to become fun for blending. So at this resolution, with this number of segments, this actually looks pretty choppy and bad. I'm going to do two things to make that better. One is I'm going to change this frequency to negative. And when I run that, it actually starts doubling back on itself when it's outside. So you can see these segments get shorter on the outside, so we get these little points and then kind of a swooping inner part here, which I kind of like. It looks neat when it blends with the pens I'm using. So that's step one. And then let's up our resolution. I'm going to change both of these to 256. So now our outer and inner circle both have 256 segments. And that's going to start to get a little nicer. So now you can see you get these really nice kind of patterns as the lines overlap with each other. Obviously, this doesn't have much fidelity with what a pen will do, but at least it gives you an idea. So let's add another epicycle to the inner circle here. I'm going to make this a smaller radius, obviously, because its impact on the circle is proportional to how big the radius of that layer is. So I'm going to tone that down a little bit. I'm also going to increase the frequency, and let's just see how that looks. I like that. I like that partly because it's not symmetrical, because the phase of these frequencies it doesn't match up at each point. So that's cool. I'm going to keep that, and then I'm going to add one more layer here. Let's do this. And I'm going to have this just a nice normal inside circle with no epicycles. I'm going to make this a smaller radius, and we'll keep that same resolution, so it'll get really dense towards the middle, which can look pretty cool. So now it's neat because these denser parts here line up between the outer interference and the inner interference pattern. And yeah, I think that's a nice, pretty simple shape. Let's send it to the plotter. So to do that, we set this emit SVG variable to true, and just run this again. So once we've seen the preview, it's created its output file. So let's switch to the terminal. And if we look here, you can see that there's an output and a proc directory. The output is the raw SVG files that we create in Python, and then the proc ones, I'll show the shell command here. The proc files are created by vpipe, and vpipe basically will make the order that the lines are drawn in more predictable and more efficient for the plotter, which is actually very, very helpful with the pens I'm using. Because they blend so much, the order that the lines are drawn in really matters. So this vpipe step adds a little time, it adds a little complexity to setup, but it makes the output just profoundly better. So now if I go into this proc directory, okay, so we'll see there's some files in here. There's these boundary files, and then these interference files. So let's open up the boundary file, like the 0th boundary file first. And it's kind of faint, but what you can see here is this is the outer boundary of that shape we drew. And so what I do is I send each of these boundaries to the plotter first, and then I do the interference lines between them. And what I'll do for this plot is make these boundaries a little darker, and then use lighter colors for the interference, and you can to get a sense of how the blending actually looks. Let's start by sending these boundary files to the plotter. I'm going to start with the outer one. I have a purple marker loaded up on the plotter, so we'll just do extensions, Xdraw control, apply, and that should draw. Cool. So now we'll go through the next one. We'll open up boundary 2.svg. That's the innermost one. And I'm going to use blue pen for that. Once again, we just do extensions. Cool. And finally, I want to do red for that middle layer. Load up the pen. And that is boundary 1.svg. Send that guy to the plotter. All right, and now is where it gets fun. Let's open up one of these interference layers. We'll do interference 0.svg. And I'm going to use yellow here. And I'm not quite sure what's going to happen with the blending, which is part of the point. So load up the marker. And send this guy. So I sped this up quite a bit. It takes about 20 minutes in real time. Okay, as this is finishing up, I realized I sort of want something in the middle of this. It's going to make the mold step a little more interesting, I think. So it's actually super simple to do that. I'll switch back to VS Code here, and I'm just going to add one more radius on the middle, or on the bottom here. I'm going to set its radius to 0 and leave everything else the same, and then rerun this. All right, cool. So now we see we've got this center block, and this looks really boring in the preview, but when we send it, the blending properties of these pens will make it a lot more interesting. So let's open up. That's going to be called interference2.svg. Cool. So it's just a little circle, and I was thinking, let's try. I'm going to try yellow again for the center. I don't want to overpower it with something too bright, and this might have neat blending patterns with the blue. So we'll send that. All right, I'm going to speed this up again. You'll note that it doesn't do the lines in perfect order. The V-pipe optimization didn't do that. I'm not exactly sure why. I'm going to do a little more experimentation, and perhaps that'll be another video. All right, and then when this is done plotting, I'll come back with the results of the scan. All right, we have a scan. So I scanned this at 1200 dpi on a flatbed scanner. So this nets us a roughly 100 megapixel file. So this is really cool because we can zoom in and see the details here. I love just how these lines overlap. You can see this was a yellow pen, but it dragged the blue in and made green and different shades of green. You can see how the ink sort of flows around the outside. Even in this orange, it's a little more subtle, but you can see where the pen goes down and sort of flares out. And then overlapping with the red here, you get this beautiful pink. I really, really love this effect on the plotter. And what this is going to do when we run the Physarum algorithm over it is, since the algorithm seeks similar colors and sort of seeks pathways along similar colors, these lines are going to give sort of some structure for the Physarum to run on. So I will show that to you next week. Thank you so much for watching, and I will see you soon.